Hello, I'm John Furrier, host of theCUBE here in theCUBE's NYSE studios here in New York. Of course, we've got Palo Alto connecting Silicon Valley and Wall Street. It's part of our NYSE Wired and theCUBE program and community. Always featuring the entrepreneurs making it happen. We got Ramin Hasani, co-founder and CEO of Liquid AI, hot startup, really kind of hitting the nerve, the neural network scene, but really kind of setting the table for what the edge will look like. And as innovation hits the scene, you're going to see a lot more innovation around algorithms and software dealing with models. Ramin, thanks for coming on theCUBE, appreciate it.
Thanks for having me.
So at the NYSE Wired, one of the things we've been focused on is kind of a community approach to what the experts are doing, what's happening in the scene. You guys jump off the page because we covered you on siliconangle.com, our site, but also you're hitting an area that we are seeing where the puck's going, and that is as the centralized resources like hyperscalers and neoclouds are spending all the CapEx, obviously for training, you're starting to see the conversation. In fact, I was having a public debate with another analyst around large language models and small language models. It was kind of like a cage match of like, large language models the only thing that matters. I'm like, well, small's good too, but like you can slice and dice. But really what it means is that as the centralized or those key resources get built out, the enterprise and then real business has to operate with devices at the edge. So we see a trend towards the edge, which points to some of the things you're working on. So let's get into it. What do you guys do? How were you formed? Tell us the origination story, how it all came together, and why this focus.
Absolutely. So we are a 2.5 years old startup. We started, spun out of MIT. We have been working at the computer science and artificial intelligence lab. We were 4 co-founders. We were all, including Professor Daniela Rus, who is the director of CSAIL, MIT, and we've been decade-long focusing on how can we bring intelligence into confined or small spaces, so which is basically devices. And for us, device at MIT was robotics. So when we were doing our research, we were thinking about how can we get inspiration from, let's say, nature and physics to build a completely new algorithm that doesn't sacrifice on the quality of intelligence when we are controlling robots, but something that actually allows us to bring the computation significantly lower so that we can have the best of intelligence actually on devices. So what we tried to do, we came up, this was my PhD thesis, in 2020 I defended, which started in Vienna and then completed at MIT and continued research at MIT. We have invented a new class of neural networks. These neural networks, we call them liquid neural networks, and liquid for flexibility. These were inspired, as I mentioned, by biology, so that make the systems stay adaptable even after learning. So if you have adaptable computation on the edge, not that they're continual learning systems, but they are more adaptable. That means they can hold more knowledge and compress more knowledge into confined spaces. So that was kind of the whole thing. We started controlling robots, like flying drones, like doing self-driving cars, and then also fixed-wing vehicles. And then we started looking into how can we predict, do predictive machine learning. This was part of our research, and we started digging into what are the fundamental properties of this technology that makes them better than what it was before in the artificial intelligence and machine learning. And then what we did, we solved a bunch of breakthroughs, and then we actually came up with some ideas about how can we take these small technologies. For example, we showed that with a handful of neurons, you can drive a car. Like 19 neurons, you can drive a car. That was like very, very small, and that became kind of nature machine intelligence papers and stuff. And then building on top of what we have done, we thought that, imagine if we scale this technology, can we go and evolve these systems for them to understand language, for them to understand vision, for them to understand audio, modalities, data modalities that humans can communicate. Yeah. So this realm of generative AI. With that mission, we started building efficient and very capable general purpose AI systems at every scale. Our first scale was like enabling kind of, from first principles, designing for, let's say, form of compute. So it matters where the intelligence goes, and that was kind of the thesis of Liquid AI. Yeah. 2.5 years ago, started in Cambridge, Massachusetts, our first office, and then our second US office was actually in San Francisco. And we are 70 people, and we have an international subsidiary also in Japan, in Tokyo. So we have been
So you're a distributed team, basically,
yes,
and you're global.
Yes.
And so the breakthrough obviously was, you came in from the robotics angle, MIT's killing it on robotics, which we've been covering too. But take me through the mindset of when that breakthrough happened, because the world's like large language models. Again, I was mentioning that debate I'm having. Most of the general public, even informed, would be like, oh, large is everything.
Yes.
Small is just as important, because now you have smaller devices, but also as the compute and XPUs and some of the hardware configurations and software, and look at CUDA, what CUDA's done, we think that's going to move to the edge too. You're going to have the ability for these small factories, these AI devices, be like mini factories. I mean, but it's distributed computing. Absolutely. But robotics and agents kind of go together too. So you got the agent wave, and then that leads to the physical AI world, Absolutely. Right? So this is kind of the trends we're seeing. Absolutely. Today it's agents, it's hyped up, well, AI infrastructure, that's where the action is. Agents come in next, and then ultimately physical AI. You agree with that?
100%.
All right, so if you believe that, then what's next? What's the most important thing right now that people should pay attention to?
In fact, like when we started the company, my vision was like to become the software layer for physical AI. Because imagine you have like a ubiquitous kind of type of software that, NVIDIAs and AMDs of the world, they're building kind of the hardware landscape of physical AI, where you can power agentic AI and then bring robotics and AI systems all around us, right? So what we thought is that like, can we bring a technology that can be general purpose enough and efficient enough and basically ubiquitous enough so that we can put them on any hardware. Users coming in, they define a use case, and then with that use case and also the place where they want to host this intelligence, be it a coffee machine, be it like kind of a mobile phone, or be it like on a laptop or a satellite or anywhere outside of a data center, we should be able to host that. So that's becoming the software layer of physical AI. So that's like what the thesis was. And we are seeing like, obviously scale enabled this new realm of kind of intelligence and the attention to artificial intelligence, because we've been working on this artificial intelligence algorithm for the last 70 years.
The road to superintelligence is coming fast, right? I mean, that's
right. Yes, and then so the thing that we started realizing is that solving the general intelligence problem is a multi-dimensional problem. It's not just scale. What are you scaling? So it's a matter of scaling data, scaling algorithms, and scaling methods. So it's so many things that goes inside this process. So when we started looking into designing these artificial general intelligence systems, generally intelligent systems, so we started looking into, from scratch. What should be the architecture? The fact that these AI systems actually got really good because we figured out an architecture which was called transformers, right? Everything is built on top of transformers. Transformers is brilliant. Why? Because they're unstructured. They're matrix multiplications, and you can build matrices of millions of parameters to matrices of trillions of parameters, And then it's just the matrix multiplication that enables like this form in like many different form factors. This is the beauty of transformers, but on the other side, they are also consuming a lot of energy, right? Like they are basically exponential. The more information an AI system processes, the exponentially quadratically actually like you're having like more and more computations. What we thought is that can we actually match the expressivity and simplicity of this kind of place, of transformers, with looking into all the other let's say mathematical operators that are available. So what we designed in-house, we didn't want to hand tweak and find out an alternative architecture. We wanted to do that systematically. We built an AI that designs AI. So we built in-house, we designed an AI system to explore through all the mathematical functions that are available, and then we told the AI, look, you want to go, I want us for you to design an algorithm that can understand language, vision, and audio, but at the same time bringing all of these things on a Qualcomm chip, on an AMD chip, on an NVIDIA chip, so basically these are kind of the criteria. So define this kind of criteria and achieve the highest performance. And then let the AI go search through a search space and find out what should be the ultimate architecture that enables kind of that kind of result. Surprisingly, we figured out that there are also smaller instances of models that can perform as good as the larger instances of the models, So this algorithmic approach allowed us to explore not just blindly scaling these models, but really figuring out what is it that is fundamentally, real about like this idea of gaining high performance kind of computers at a given capacity.
And with a certain intelligence level.
Correct.
And having the kind of intelligence at scale, you've done both. It's interesting, you mentioned scaling, I've given some talks with Bill Tye, Brian Bauman and I have talked about matrix multiplication, and a thing with Bill Tye says, it's just matrix like in high school. This is where the GPUs come in, and I think that's where you see the NVIDIA getting the wins here. And so that's one. You know, in the old computer science days when you built software, the expression was, you know, garbage in, garbage out. The same could apply to scale. You can scale garbage too, right?
Absolutely.
So like, scaling is not the one thing. So I want to ask you about the scaling laws involved and some of the things you guys do. And the other thing that I want to ask you is, last year at NVIDIA GTC in San Jose, Jensen Huang was on stage and said, KV Cache is the operating system for AI factories. And I'm like, well, that's not an operation, that's networking. So networking is the new OS, and that's basically what he said. And we believe that too. So networking as the fundamental OS, that's counterintuitive if you're a CS person, but not really if you think about it. So talk about the impact to scale, why managing the models at scale, big and small, and then the role of networking to your impact at Liquid, and also to how people want to design hardware.
Absolutely. Well, high bandwidth memory, you know, like that's like the whole thing that is actually the holy grail right now. Memory is extremely important, like as you think about it, like, and the speed of communication for a long context kind of memory is like, again, it's like the crucial kind of component of any future intelligence system that you want to build. So obviously, Jensen is talking about that kind of memory.
More tokens, baby. Like spend more, save more. Or make more.
Yeah, which is brilliant.
We call that Jensen's law, tongue in cheek. But no, it's true though, we mean more tokens.
Absolutely. And then, see, you know, you can be smart about tokens, you know, and the consumption of tokens as well. You know, so what we thought is that, all right, so you need memory. Let's deeply think about the computations that goes through computation of memory at larger scale. So that means like the challenge is always this, like, scale, as I mentioned, scale has like multiple dimensions, you know. One scale is like parameters, number of parameters. Another scale is like the scale of data that you can process at inference, at the test time, you know. So the bottleneck is always the algorithm that becomes quadratically kind of expensive. Can we reduce this cost, you know? When you saw that DeepSeek moments and all these other things, they were all about efficiency.
Yeah, innovation, that was actually innovative.
Absolutely, because we want to really like reduce the cost. Why? Because at the end of the day, what we want to enable like reliable, long context kind of memory interaction with the data that the user has, you know, and then, you know, satisfy like a data job that a person has to perform like with much more efficiently, you know, and you know, like we build Liquid AI on the foundations of efficiency. So in fact, I would say like efficiency is our DNA, you know, because we're thinking about algorithms like extremely like across the stack. When I say stack, a stack of foundation model development, you know, when we build models, the economics of Liquid is that the more information you want to process, the cheaper it gets. Very similar to how Jensen does it.
Would it be safe to say that Liquid AI is AI for AI? Or how would you describe?
I would say you're a foundation model for devices. So let's say if you want to bring in intelligence systems like ChatGPT experiences, multi-modal kind of systems that perform very reliably with high performance on a specialized applications, and you want to serve them, let's say, immediately on your entire cars. You know, imagine you're an automotive company and you want to build in-car intelligence. You cannot rely on the cloud, you know, so you have to have intelligence on board. What is on board? There on a car, usually there is like a small little computer, you know. So you want to be able to bring in like all these amazing generative AI experiences, and also as good as ChatGPTs of the world onto that car. This is where Liquid comes in. Imagine you want to power Apple Intelligence, the device portion. Samsung Intelligence, the same thing. You know, you want to have like a smart TVs, smart devices in your home. You know, imagine you want to have places where you don't have access to internet, places where privacy becomes very, very concerning. You know, and you want to immediately get access to intelligence. You're talking about sovereign AI. You know, imagine you want to deploy AI in like global scale, like let's say for your entire citizens of your country. You know, you want to enable AI, but then immediately you don't want to pay billions of dollars first, but first, what you want to do, you want to basically bring in top down, you know, like everybody has access to a mobile phone, a tablet, or whatever. However, we can run Liquid foundation models on Raspberry Pis. So if you can run them on Raspberry Pis, that means like you can bring intelligence on the edge for everybody.
And that changes the whole equation. By the way, DeepSeek, one of the things I like about DeepSeek is it's a tell sign, it's an indicator that you can use old school stuff. I mean, they were reverse engineering CUDA and didn't have access to the big GPUs, so they used the old one. But it speaks to the bubble problem, because there's no bubble if you can reuse H100s. Absolutely. Or GB200, whatever's out there can be reused. I want to ask you about architecture, because you're bringing up some really cool points that we're watching. If you go back, say 10 years ago, or even 8 years ago, the cloud was great. Cloud computing and SaaS, and the cloud was viewed in all technical circuits as a horizontally scalable system. Yes. You don't have to buy a data center, you go in the cloud, they had higher level service use, it's horizontally scalable. If you look at what's going on now with what you guys are doing, and what we were just talking about, is that the network's now the horizontal scale, and you're vertically integrating into the cloud. Do you believe that to be the new architecture? Because that flips the script, because now you can say, hey, I'm going to horizontally scale across devices and then go to the vertically integrate to the cloud for other stuff, whether that's Azure, AWS, or Google, whoever, Oracle.
Absolutely.
You believe that?
I think so, because if you think about it, there's always like a circular kind of story about like we're going to the cloud and then coming on devices, And I think this story is now on repeat right now. So I feel like now we are entering to the phase where eventually the world is going to be a hybrid kind of solution.
Yeah, it's distributed computing.
Exactly, and I think we are getting there. The edge is improving a lot, and computers, as you saw, like the NVIDIA announced like the little things, and your Mac Studios are amazing, and you see like that.
I mean, you're already seeing, you got the Thor silicon from NVIDIA, Prometheus chip from Amazon. These point to the fact that the devices are going to have, terrestrial and space. You're talking about, this is the new edge. What's your vision on that? Because if the devices get faster, probably there'll be new hardware reference implementations. That means what we know today as a device, a Wi-Fi access point, will change. We all have phones. We're going to have pins, or whatever they're calling these devices. Yeah. We're going to have things.
Glasses, small
glasses. You have, personal area networks are coming, so retail's impacted, healthcare will be impacted. The inbound data coming off the edge, right now inference is the hot topic, but no one's talking about training. That's new data coming in, and most of the AI factory or physical AI work is synthetic data. So how do you view that? How does your mind think about that? Because the possibilities are, okay, intelligent edge, true intelligence, not like industrial manufacturing use case, which is great, by the way. But
absolutely.
If an intelligent edge comes, you need training and inference, and you need AI to figure out what to do on that device.
Absolutely. So
what's your thoughts on that?
Think about it like this. So we're talking about what you say, training, inference, what's the common denominator of the future is adaptability. You want adaptive computations on devices, So if you can enable something like that, that's great. So this is where we got started, with liquid neural networks. Like the ideas were like, can we have like continuously adaptable systems that are like much more kind of resilient to input data, and as they receive, and be able to perform in novel environments or on novel data, like the same way that they perform on the like on the training data that they have seen, So this comes very much into the thesis of what we're building in the future. There's innovations across software and innovation across hardware that is required to enable that adaptive form of computation. So what we believe is that a co-development between the two, software, hardware co-development, is something that is absolutely essential. We're working very closely with AMD. We're working with like all the other providers, like Sony's of the world and Qualcomm's of the world, and like with everyone that we talk to, it's like the ideas are like basically enabling that kind of future, and I see future of computation, future of chips are going into that direction of hosting more adaptive form of computation. These adaptive form of computations are, if you think about it, is like basically being able to train on an incoming series of data, as you perform the forward computation. So you can perform backward computation or recursive self-improvement, performing that kind of operations. And that is kind of the future.
And that's real data, by the way, too. That's not synthetic data. That's going to have huge value.
Yes.
All right, Ramin, you guys are really in a good spot. I like what you guys are doing. It's got the direction that we see, too. Let's zoom out. Let's talk about kind of where you are today, because you're in the pole position. What's going on with the momentum? Can you share some stats? Where the momentum is, some of the deals you're doing, what's going on with the company?
Yeah, absolutely. So, It has been incredible because I think everyone is starting realizing like how much you can get out of small models. Like recently from a product side, we released a series of small foundation models, which we call them nanos. These are liquid foundation models, LFMs. They're very tiny. Imagine like a 300 million parameter model performs as good as GPT-5 on specialized applications. That's what we are enabling today. So now,
so small is better for specialized applications.
Exactly, and if you see, the challenge of small foundation models was always quality. When you make the systems small, they can go and match inside the memory of a device, you know. But then they have to be fast, low latency. The biggest challenge is that how much intelligence can I get out of this system? You know, how intelligent is this system? Let's say you want to do document summarization privately on a device, you can do that. Let's say you want to identify kind of personally identifiable information, PIIs, kind of, you want to mask out like kind of those information, you can do that. Let's say you want to build agentic AI for like a full loop of like, let's say multiple models like working together to perform booking your travels, you know, or calling an Uber for you or something. And if all of these things are going to be, they're kind of privacy sensitive kind of information. So what you want to do, you want to do computation directly on device.
And have policy on that too.
Correct.
That's where the chips come in.
Absolutely. So then for all of these values that I mentioned, like we're building like these foundation models that can process audio, text, and vision, plus signal. Other types of signal. So we are also working with financial time series and stuff because our models are like from an architecture point of view, they can process any data to anything, you know. So that's kind of our specialty. We see in two industry clusters, we see like a lot of attraction. So one is OEMs and original equipment manufacturers, which is like consumer electronics, automotive, and all those places. And then another one is in financial services and e-commerce. In financial services, what is very fascinating for what is the work of small models is the fact that they can be extremely low latency. Today we have models that can go sub 10 millisecond in activation. So imagine a bulk of text coming in, how fast you can complete those. Okay, so that's
and
an
then you can still talk to the large language models and cache it.
Absolutely.
I mean, this is where this is the hard way. Ramin, we ran out of time. Definitely would like to have you back. I think that you're in an area that bridges the agentic to AI factory, physical AI world, robotics, every use case. I mean, the disruption on the business model transformation. Again, the new architectures are kind of coming. It's not it's counterintuitive, but the cloud's vertically scaling. I mean, they might not like that, but that's what they are. I mean, it's resource.
I would tell you that the future is going to be a hybrid solution where the most sophisticated applications of AI, let's say AI scientists, is going to go on the cloud. And the more kind of tasks that you want to perform reliably, privacy sensitive, latency sensitive, and efficient kind of implementation of these AIs are going to stay on the device, and there will be orchestration between the cloud and the device.
Well, all that's matching what we're seeing on our research side. Really appreciate you sharing your insight. Congratulations on the success, funding, big Series A. We'll be chatting further. Thanks for coming on.
Absolutely. Thank you.
I'm John Furrier with theCUBE here at the NYSE CUBE studios, breaking down all the leaders in the AI factories, the future of the data center, and the edge obviously is a data center too. The devices are getting smaller, faster, cheaper, more intelligent, and as the models need to perform at the edge with real data, you're going to start to see a whole nother architecture. Liquid AI is one of the companies that's looking good off the tee, as they say. I'm John Furrier, thanks for watching.